In this lesson, we will be graphing systems of equations. Okay, so in the first part, we're going to check to see if the system has either no answer, one answer, or infinitely many. Okay, so when we're talking about a system of equations, we mean two separate equations. Okay, so the solution right here is given as an ordered pair where the graphs intersect. Okay, so right here, let me put it in red, is where the graphs intersect. Okay, and the point here is 2, 2. So we can say that this system of equations has one solution. Okay, so just to go over a little bit of vocabulary, two equations graphed together are called a system of equations. If the graphs intersect the system, it is called independent. If the system has exactly one solution, it is called intersecting. Okay, so they intersect to form exactly one solution. If the system has infinite solutions, okay, it is the same exact line. That means that every solution is an answer. If the graphs are parallel and thus has no solutions, then it is just called parallel. Okay, so let's look at this on a couple of different graphs. Okay, so here we see that the three types. Okay, so if I had a graph that looked like this, okay, I would see that I have one solution. Okay, and so the name of this would be called intersecting lines. Okay, the next example would be a graph that is like here, and then the next line is right here exactly on top. Okay, so I would call this many solutions. Okay, another name for the word many is infinite. And then this would be considered the same line. Okay, so in this case, the slope is going to be the same, and so is the y-intercept. Okay, the next example is when I have one line here, and the next here. I guess I should make this one into blue also. Okay, so here, this one would be considered no solution. Okay, the lines never intersect. Okay, so here the lines are parallel. Okay, so we know that for parallel lines, they have the same slope, but they have a different y-intercept. Okay, so let's try and do a couple of these. Let's see how many solutions that we have. So for part A, y is equal to negative x plus 5. So let's find that line, which is right here. Okay, so we're talking about this line and the line y equals x minus 3, which is right here. Okay, so we see that these are intersecting, so they have one solution. Okay, so try and pause the video and try parts B and C and check back. Okay, so for part B, we're going to find y equals negative x plus 5, and then the line for negative x minus 4 is right here. So you see that these lines are parallel, which means no solution. Okay, and then the last one, choose a different color. So 2x plus 14 is this line right here. And negative x plus 5 is this line right here. Okay, so we see that in the purple they are intersecting one time. Okay, so just to review a little bit about slope-intercept form and standard form. Okay, so just to review that slope-intercept form is when we find the y-intercept, okay, and we plot the point, and then we use slope from that point, okay. Standard form, to graph this, we can cover up the x term and solve for y. okay? And then cover up the y term and solve for x. Okay, so let's try both of these. Okay, so this one right here is in slope-intercept form. So if I want to, I can cover up the x value. If I cover it up, y is equal to 4. Okay, so in this case, x was 0, y is 4. Okay, then to get the other point, I cover up the y and I solve for x. Okay, so here y would have been 0, and x then would have to be 2 because 2 times 2 is equal to 4. Okay, then I can graph these 2 points, 0, 4. Okay, so here let's look at the first one. So if I want to graph my first equation, I'm starting at 2, and my slope is 1 over 1. So rise 1, run 1. And my second equation is starting at 1, and my slope is 2. So rise 2, run 1. So I see that they are intersecting one time right here. Okay, so my solution is one solution. Okay, moving on to the next one. So if I start at negative 4, my slope is 3. Rise 3, run 1. And my other equation is starting at 1. So negative 2, 1. Okay? So I see that here they both intersected at this point, so my answer is one solution. Okay, this point right here is 1, negative 1. Okay, and I forgot to mention on the first one that this point right here is 1, 3. Okay, so if there is one solution, you do want to state what it is. Okay, so pause the video for a moment and try these two on your own. Okay, so for this one, you should have started at negative 4. Rise 3, 1, 2, 3, run 1. Okay, and then the other one is again starting at negative 4, except here we have a negative slope. Okay, so if I rise 3, I'm going to go left 1. Okay, so I notice that these intersect right here at one point, and that is the point 0, negative 4. Okay, that's the intersection point. All right, the second one here, if I want to graph, I can start at 1. My slope is negative 1, 1. And then I can solve two ways for this one. I can cover up this and say that when x is 0, y is 1. And then I can also, if I erase back, I can cover up the y and say that when y is 0, x is also 1. Okay, so I can connect these 2 points. So 0, 1 would be right here, and 1, 0 would be right here. And we notice that this is actually the same exact line. Okay? Another way you can double check is to put this second equation here into slope-intercept form. If I did subtract x on both sides, I would end up with y is equal to negative x plus 1. And I could also see that, yes, this equation is in fact the same as here. Okay? So this would be an example of infinite because it is the same line.